Welcome to qnawire.
We want to use the formula h equals negative 16t squared plus the initial velocity, which is 40 feet per second, times t. A ball is thrown straight upward at that initial speed of 40 feet per second. We first want to know, when does the ball reach a height of 24 feet? You can do this by setting h equal to 24 and solving for t by subtracting 24 to both sides and using the quadratic formula. The quadratic formula would be when t is equal to opposite b plus or minus the square root of b squared minus 4ac all over 2a. You could simplify this by reducing all the coefficients here by a factor of 4, but that's all right. So I'll go to a calculator, negative 40. I'll start with the plus square root of negative 40 squared. No, I'm sorry, 40 squared. Not that it actually matters, but 40 squared minus 4 times negative 16 times negative 24 all over 2a, where a is negative 16. And that would be equal to 1. If we were to do the minus, we get 1.5. So when does it reach a height of 24 feet? That would be at 1 and 1.5 seconds. For part B, when does it reach a height of 48 feet? So then 48 is equal to negative 16t squared plus 40t. And 0 equals negative 16t squared plus 40t minus 48. So we're equal to 0, and we go back to the quadratic formula. The only thing that changes is the c value is negative 48. So I'll just go back to the calculator and change that part of it. And it's undefined, meaning it doesn't hit that point. It never reaches 48 feet. Let's confirm this graphically. If we were to graph negative 16x squared plus 40x and then subtracted 48, or even just looked at the original, we can see that it only gets as high as 25 feet. So it doesn't exist. C. What is the greatest height reached by the ball? Just answer that, 25 feet. We can figure this out by opposite B over 2A. So that happens at negative 40 over negative 32, which would be 4 goes into both. That would be positive 10 over 4, 8, so 5/4, or 1.25 seconds. And then we find h of 1.25, which is equal to 25. When does the ball reach the highest path? At 1.25 seconds. When does it hit the ground? That's when the function is equal to 0. So that would be negative 16 t squared plus 40t. We could do this one by factoring. we could factor out a negative 4t, and then we'd be left with 4t plus 10, so we could actually have done 8. Let's do even more. Let's factor out a negative 8t. You can still use quadratic formula here as well. So this would be 2t minus 5. And so this would be at when negative 8t is equal to 0, or when 2t minus 5 is equal to 0. So that would be at a time 0, or add 5 and divide by 2, 5 halves, or 2.5 seconds. So when does it hit the ground? 2.5 seconds. So we can confirm this graphically as well. When the trajectory hits the x-axis, that happens at 2.5.